Hi. I want to talk about arrow functions or arrow expressions today. And first I want to tell you who I am, because I think since I'm here for the first time, nobody knows me that well. Well, okay. Let's continue. Hi, I'm Juri Leino. I've been developing JavaScript for 15 years now. I think it's even more than that, 17 maybe. And I loved with JavaScript that it was immediately interpreted, and that was kind of punk rock. Almost everything that you wrote worked in a way. And I also like that it is impure, so that you don't have to adhere to certain things. It will usually somehow work. And you can do a lot of things, even if it's not the right way. What I also like about JavaScript is that it can be found anywhere. So it was recently deployed to satellites as well. So yeah, nowadays you have it. Is the new assembler, kind of. But in the last 3 years, I was working for a company called Exist Solutions. So working on ExistDB and writing a lot of XQuery. And first new function or first new feature that I saw from XQuery 3.1 was the arrow expressions. Let me just quickly recap what an arrow expression is so that everybody can follow. It will take this A, evaluate it, and put it into the function that is after the arrow, and put it there as the first parameter, always. There's no way around that. And whatever is on the right-hand side of the arrow expressions needs to be a function call. So this is an example that you see here. We take the string hello Prague and put it into a function called uppercase and then tokenize it, which would be the same as calling them in the traditional way of wrapping all these function calls after another. This one, I think the upper one is fairly more usable. And this is why I looked more into that, because I thought, yeah, this looks like a good feature. Interestingly, this is a pipeline operator. The arrow expressions are kind of a pipeline operator, and JavaScript wants to have that too, so it's in the proposal right now. It's at stage 4, I think. Not sure. What I learned along the way, I had to reread the spec for 3 times, I think, before I really got to that point that I can explain it to you now, before it really clicked in my head. So I wanted to share with you what you have to keep in mind when you want to work with them. I love functions. So the first thing I thought, hey, let's put an anonymous function on the right-hand side, but this doesn't work because it's a declaration instead of a call to that function. So you need to put extra parentheses around this to make it a function call. And this above example would evaluate to just this function called with 123. More stuff I learned along the way is you cannot use the arity notation. This will always throw in all runtimes I've tested, at least. And there is no context item, so you can't use that as well. And this above line will not create what you think it would, but you will get an anonymous function back. Also, it's really important to note the difference between the arrow operator and the simple map operator. If you put count behind it, the first one doesn't have any parameter, and the second one has one, but they will produce a very different output as well. While the first one will really count the sequence items, the second one will count each item in that sequence. So You can chain these. Simple map operator can be changed that way, that you just call it after another and will do what you think, and you can do that with an arrow operator as well, but can we combine those two? In fact, we can, but you have to adhere to a certain set of rules. That means that if you have only an expression after the simple map operator, you need to enclose it in parentheses. After that, you can safely use the arrow operator again. If you have a function call after the simple map operator, you can get around those extra parentheses because it will notice, okay, yeah, this is one expression only, and will know when to call what. If you use an arrow operator and want to use a simple map operator after that, you have to enclose the whole arrow, both sides of the arrow expressions, or both sides of the arrow entirely. Otherwise, the simple map operator doesn't know what to act upon. At this point, I would like to just very briefly brush over functional programming because I will use it a lot. So higher order functions. I do love pure functions because they have no side effects. You can do all kinds of interesting compiler optimization with it. I think this has been part in this discussion here as well a lot of times before. There's also functions, returning functions, which I will use a lot. But don't worry. I mean, after Michael K. said it, higher order function is the cool new shit, and we all should use them. Partial application is something that's really important here to know about. So if we have a function called local add, which takes 2 parameters, we can create a function reference to that function by putting a question mark on either side of them. Because it's a commutative operation, we can do that. It doesn't change the outcome of the function. If you would have a minus there, then we would have to definitely know where we want to, which parameter we want to replace. So now there's already the simple map operator and followed by an arrow function, and we will now add 48 to each of those items. That will give us another sequence of numbers, and if we give that to code points to string, it will output to 2,138. Well, that's not so impressive, but let's see where we can get from here. And I think, I don't know if that's really readable, that above, but that's usually up to the person or the developer or the team what is readable. We also need to briefly talk about higher order functions. That is a function that is parameterized by a function or also returns a function. At least the XQuery spec says it's also a higher order function is a function that returns a function, but I'm not sure about this, if this is really part of category theory. If this is in their mind a higher order function as well. I'm not sure. So we have function arity, which I use at this, this function will return the function where the arity matches. Will return the arity of the function you are giving it. And for instance, count, that would be 1. And it's very useful if you want to do certain things that I will show you later, to know the function that, the reference you have at hand, how many parameters does it want to get. There's also function name and function lookup, but they're not that interesting to me. Really interesting it gets when you look at those basic higher order functions, which I don't know if they're really basic to get, but if you have them and combine them, then you can do a lot of interesting things. I will mostly focus on for each and filter and sort and fold left because these are a good set of things to do. Function apply has its uses, but it's rather niche. fold right as well. Fold right is really cool if you have something that is, can be optimized by tail recursion, but I have a hard time finding things in my day-to-day developing life where this is useful. And back to our function that we had before, I hope you have them in mind, but they're actually named add48 and add16, so that's kind of obvious what they do. So if we now provide for each this function reference, it will apply this to each item in the sequence, then give back that sequence, and again, we will for each over this and add 16 to each item, and again give it to call points to string, and now for it returns Bach. I don't know. Interesting, right? So with all that said before, I thought, can I program in XQuery using no flower operations at all? It's a bad pun, I know. But I couldn't resist. Why would I do this, right? Why would I just throw flower operations completely away? I mean, they're widely used and they're well known. It was just to trick my mind to be more creative or find new stuff. It's a technique called creative constraints. And you can use that, for instance, yourself. If you say you do a code kata, this is, say, do this in 15 minutes. Or do this only by functions with array2 or anything. There's like, yeah, there's no limit to what you can, there's really no artificial goal that or limit that you can set that would help you in that. And one really interesting one is programming without else, which I used for years now, which has really interesting side effects that will keep your functions short, but it's only useful in a language that allows multiple returns. I will come back to that later. So, how do I do it? For and let can be replaced by for each, in that sense that for obviously iterates over something, and let just adds some new values to each item. So in for each I can do that. Both are replaceable by for each. Order by is obviously replaced by sort, which takes functions as well. And group by is a little interesting. It was harder to really get, but reducing or fold left does the job really well, interestingly. And where is, yeah, replaced by filter. So after a while, I thought, hey, I have it. I have something here. And I called it crossbow. I wanted to create something that is a library, a set of functions that would make working with the arrow expression really easy or comfortable. Something along the lines like jQuery has done for JavaScript a ton to really drive adoption for certain features. And also, I think about it like functx, but for arrow expressions. And I need to shout out Priscilla Walmsley here, because what she did with functx is, I think, really impressive. I myself learned a lot reading her code and seeing how she did this. And also, it is widely used, at least this is my impression, that functx is found in a lot of projects that do stuff with XQuery. The first set of things I came up with is numerical comparisons. Kind of a no-brainer. I'm just wrapping GE, GT, LE, and EQ, and LT in a function so that it can be put after the arrow operator. How does it look in practice? So I have this function, crossbow GT, and I give it a 5. What I get back is a function with array1. It accepts one numeric, any numeric. Actually, it accepts any item. But, well, we come back to that later. And now I can have some expression and follow it up after an arrow with XQuery. And what is this? Now we have extra parentheses after this. We need to add those because it needs to be a function call still. So you cannot get around those. But it really shines if you put it into filter, because now you don't have any extra wrapping parentheses anymore. And yeah, it does what it should do. So my sequence from 1 to 9 will only be filtered by it, and only the items that are greater than 5 will be returned. There's a ton of helpers now. I don't know, if you start writing, all of a sudden you see this and that, and yeah, that could be useful. So there's a lot of things you can't do after the arrow. Is like there's this shorthand question mark stars to create a sequence out of an array. So this is wrapped in a function and all these kind of stuff. Just to have it be possible to use after an arrow. There's functions that are likely will not be where did the name kind of wrong. Map reverse does flip the map actually, so the keys will be the values and the values will be the keys. So they will be renamed likely. And yeah, sort by is just a very simple wraparound sort. For each index is a thing that I will come back to, but it's actually something that is a little like the JavaScript implementation of for each and map, like they call it there, map. And it will not only give you each item, but also the position in that sequence or in that array. Because for each index does accept a sequence or an array. It will internally figure out what you really want to do. Here's some artificial thing I came up with to show you what you can do with those library functions. I have, again, this sequence of 2, 1, 3, and 8, and I sort it in descending order, and then I take the first 2 elements of it and I convert it to an array. And you get back an array of 8 and 3. Here's for each index that I brushed over 2 slides before, and yeah, you can do all kinds of stuff with it. This is an artificial example. You just convert each item into an array with position and the item value after that. Can you see those gray examples, the return values? Okay, good. Because the contrast is not that good. So this is essentially how the JavaScript implementation of map and for each works. You also get the array itself or the sequence you passed in, which can also, I think I will add this as well in the 2.0 release of Crossbow, because then you can do something like an average over the last 3 items, or yeah, so windowed flower expressions, I think, is possible to make it. I don't know if it will be performant. I'm just saying it would be possible. There's also, interestingly, a function that wraps just element to create an element after an arrow operation. So it's essentially that what we will maybe have in the future, or likely, or hopefully get in the future, a function that creates an element. And I will either use that XQuery function then, or just drop that feature from the library. I'm not sure yet. Depends. Well, there's more of them. There's like wrap each, so you could give it a sequence, and it will wrap each of those elements in that, each of the items in the element you want. And filter attributes is just you give it a node and then you get back all attributes that were in the sequence you passed it in. And attributes to map is actually just a filter to get a map out of a sequence of attributes with the element name as a key and the element value as a value. Now to the more interesting stuff. Reducing. Reducing is a very powerful tool. Here I said boil down a sequence to a Boolean. Actually what I mean is boil down a sequence or a set of things to a single value. This single value can be arbitrarily complex, so it's a little, yeah, you can abuse it as well, but I use it a lot. I implemented wrappers, or these are not wrappers around some, all, and none. At least some is part of the XQuery spec. I don't know if all, yeah, all is, I think as well, I'm not sure. But these are actually different implementations, so I use fold left inside of those functions instead of just calling sum. And they work really well. So they do what they should. Now I have this function group by. You give it anything, a sequence, and there's a helper as well that says even odd, and then you will get a map back with even items and odd items. You can paste, or you can pass it an arbitrary function and it will produce a map out of what the map will return. I will add an example for this to the documentation. I think it should be there. One really interesting thing I've got from a library that I really love, D3.js, is that they use accessors a lot to get to a value from a complex item to a single value that you then can compare or reduce or or group by. And I saw actually that is also part of the spec recently. It's in the data model. You have accessors as well, so I don't know. I will still show you how they work, so it shouldn't be that hard to understand. String data and node name and niled are accessors. We have, for example, a sequence of maps. Each has just a view, but they could have arbitrarily many fields, each of them. And I want to act upon the number of views now, because we all love numbers, and views we want more, right? So all of these functions here, all the three, they will do the same thing. They will retrieve the number of views for each of those maps. And I like that you can use mapget with a question mark, but you still have to remember that, which can be kind of hard. Therefore, I opted to write a function that only, yeah, you just give it the field you want to get and you will get it. And there's also plug deep. I don't know if that's a cool name. I just called it that. Yeah, it might change in the future actually to maybe crossbow get. And you can give it a sequence of fields and it will traverse into that map deeper and retrieve that value from there. So, I have my posts. Now I iterate over them to get all the views. And I filter out the ones that are greater than 10, that have more views. The good ones, right? And I get back my sequence. And it's cool. Now I can do an average and I see which of my successful posts has in average how many views. But what I lose, and this was also part of the proposal yesterday, is I lose the item itself. So now I can give this accessor to greater than to the function, and will instead get back the items that I originally had. And I see I'm running out of time, so I will have to be a bit faster now. Sorry. So you can do this with all kinds of stuff. You can with an array out of nodes. And here comes the really interesting stuff. So I came up with a function that is able to combine functions and then run all of them. So if you have a really large sequence and have like 3 for each in a row, they do different things. You can now combine them, and the sequence will not be iterated over 3 times. Categorize. So I have stuff, and I want to know this is this category, this is this category. This can be done with an array of rules and the function categorize and an accessor function as we had before, and now I get an array out of items that match that a certain category, and then I can label them to see, okay, I want to output it on a website, for instance, and yeah, have then a label attached to all of these, if you need that. It's not necessary to have that, a label. You may want to do other stuff with categories. The for each index I came up with before allows me to do something like array fill, where I can pass it a function, and my array will be filled with the return value of that function. Here is an error. The number of items should be here. So how large my array should be is there. And I can do interesting stuff with it. As you see, I now fill an array with a quadratic, a set of filters that are well, I'm running out of time, but the like 2, 4, less than 2, less than 4, less than 8, less than 16, and then I can categorize them accordingly. Okay, so let me stop here. I don't know if this is readable, but I think this is something that will evolve. So language evolve, and I really want you to take part in that evolution. And thank you very much. There's a lot of things I wanted to talk about, but I'm running out of time. Sorry. Go shoot some arrows.
Thank you, and I agree that we are not too hungry, so we can still do the questions. So, questions, please. A lot of them. Okay. So 1, keep your hands. I will assign you numbers. Abels first, Matt second, third, fourth, fifth.
Oh, a lot of questions.
Oh, wow. Okay.
I really liked your talk about... I'm here.
Ah.
Hi.
Okay.
I really like your talk about using higher order functions in this way and with the arrow operator to have some form of applying the functions in after one another. And it fits very well with Michael Kay's talk yesterday in, where he asked, we need more higher order functions to work with, otherwise people are not going to use it. And I think you just made an excellent library here. And there was one question you asked yourself. There was about when is something a higher order function. And in my view, it is whenever you have an item or a value, so to say, that references a function, then then you are using higher order functions. It's maybe not the official definition, but
it was more about the returning part. Is a function that returns a function automatically in higher order function? I'm not
yes,
sure
because
about
what you're returning, you have to capture in, let's say, a variable, or you have to apply it again. So yes,
okay.
that is also higher
Okay.
order functions.
Yeah.
Anyway, thank you very much.
Thanks.
Yeah, could you just pass the mic to Matt, because he's the second in a queue.
Hello, I'm over
Hi.
here. That was very interesting, thank you. I was wondering if you looked at other languages for inspiration for some of the more compositional aspects. So with Ruby's enumerator, you typically you wouldn't do necessarily something like for each index. You do an enumerator that has generated a new sequence with the index, and then you'd map that. And that works because you have lazy evaluation. So you're not actually doing 2 iterations of the array. You're just kind of doing all the steps kind of one at a time going through. And I wondered if you thought about trying to implement lazy evaluation for that kind of stuff in XQuery. And the other question is,
Okay.
sorry?
Yeah.
What was my other question? Partial function application. It looked like things like your greater than thing. The thing that would be lovely is if some of the built-ins would just, like, if you didn't give them all the arguments, it would return a function that then if you call that function and supply the next argument, and then you'd get what you want, which is the kind of thing you get with function currying and partial function application in things like Haskell and other stuff. And it's kind of super interesting for the kind of use cases you were looking at, I think.
Yeah, well, you could do that. You could write a function that, like I showed before, the reference to add48 is exactly that, right? You have a question mark. But your first question was if I would do something that could use lazy evaluation. Well, it uses fold left in the background, so it's actually only going over over the sequence once.
Yeah, it's not lazy.
Yeah, well, but
It doesn't have to evaluate it, it's still evaluating.
yes, but it has to be evaluated. Well,
Yeah. Maybe you can discuss this
Yeah.
detail over the lunch, and we will pass to the next question.
Yes, you had a page with errors, and one of the errors was a sequence of values, and then an arrow, and then the stop. And I asked Michael K. yesterday, so according to him, it should not return a problem. So maybe this is an exist implementation error and not a spec error. Have you considered that?
which one?
Well, yes, on your page with early in your presentation, you mentioned a few things that returned an error.
Only the first two returned an error. The third returned a not what you think it would return, but a function.
Yeah, so I think it was
Not a
the
value,
second
but a
one.
function.
But the question is, should it return an error, or is that an implementation problem?
No, it doesn't return an error. It's cool. Maybe we discuss that later as well.
Okay, you are next for the question.
Not a question, just an observation. Thank you very much. A lot of great ideas there. Apologies in advance if I steal some of them. I hope you'll take that as a compliment.
That's cool, that's cool.
I think it was me that first proposed the arrow operator, and I never imagined it turning out to be quite so powerful. So I'm very pleased to see that. Thank you.
And the last question.
So I don't know if you know the work of IFIP Working Group 2.1, who do a lot of similar things to what you're doing. One of the things I really like about what they're doing is that they've turned it into a mathematical notation, and with sort of general rules like in mathematics, like commutativity and things like that, so that you can transform programs sort of almost automatically from one form into the other. Mm-hmm. And they've done, it's called the Bird-Meertens formalism, that is what they did this work on. And it's quite exciting stuff, really.
Okay, I want to look into that.
Okay, I don't see more questions, so thank you very much again. And obviously there will be lunch now, and we will meet in this room again at 2:30.